Good morning and good afternoon. Welcome to the webinar. My name is Taji Joseph, an application engineer from Leap, Australia. So let us start considering some of the common challenges that facing many organizations today. Most companies have a disconnected solutions that are used throughout the product development process. The result of a disconnected workflow is that they cannot be automated or streamlined to increase the efficiency and the productivity. Now, with the Creo solutions, customers are able to support a fully integrated design and development process. And advantage is that when there is a design change, drawings, analysis, tooling, manufacturing sequences are automatically updated to reflect that change. Now, Creo provides a comprehensive suite of manufacturing and tooling solutions to support the smooth transition from design to manufacturing. In addition to the conventional tooling and NC machining, Creo have the best-in-class tool for modern manufacturing as well. So in today's manufacturing field, there are so many emerging technologies to boost the manufacturing. Additive manufacturing, metal printing, and hybrid machining is evolving. And there is so many advancement in the high-speed machining and 5-axis, which reduces product development cycle and the manufacturing cost. And we see how these emerging technologies inside Creo to help us, to boost the momentum in the industry. So I'll be focusing on additive manufacturing and 5-axis machining today. So let us first look at additive manufacturing inside Creo. Now, inside Creo, we offer a complete solution for additive manufacturing. Now, starting from design and then optimize and validate, and then finally 3D printing, everything in one single system. Now, when we discuss about metal printing, support structures consideration is very important. And the first thing we will do inside Creo is we can predict the support material with the optimum build direction. In the wrong orientation of the model in the tray may affect the functional aspect of the design and surface finish, and that can lead into a complex post-machining operation. And then lattice creations are another important steps in the design of additive manufacturing. Lattices have so much advantages. They offer lightweight design, improve the flexibility, but it is not just the geometry. How I can keep the mathematical definition and then take it to the next process of analyzing this model to solve the structural problems, the vibration control, and so on. And Creo offer a wide variety of simulation capabilities and dynamically update the result as the user make any geometry changes or setup changes. And finally, store all this information in a tray and export or connect to a 3D printing machine directly. And again, it is one single system, and a change made us anywhere in the design process will automatically propagate to the downstream. Okay. And now let us go a little bit more deeper into have a look at the different functionalities within the additive manufacturing suite. So first, let us have a look at the lattices. Now, lattices in Creo start with the basic 2.5 axis lattices and 3.5, the 3D lattices. It is a fully configurable system. It's like you can completely change any definition in the lattices. And then we have formula-driven lattices, create self-supporting lattices geometry for additive manufacturing. And 3D printing users really love this. It will reduce the time they take for post-machining the support structures. These continuous, surfaces can serve some of the additional functional purposes. Something like shock absorption and thermal transfer is good for lightweight components. Then another type of lattices in Creo is stochastic lattices. They create some interconnected beams that conform with the shape of the part. They create a form-like material that could be used for really good for bionic shapes if the bone should need to grow inside the implants. And finally, any custom lattices can be created inside Creo, and we can then use those curves to create the beam-based lightweight models, which will help us for the quick AFI analysis result. Now, when companies use Creo additive manufacturing extension together with the Creo Simulate, they have a single environment to design, analyze, and optimize lattice structures. We can convert the lattice structures into lightweight beams and shells to speed up that whole process of simulation. And finally, metal printer tray optimization. Creo additive manufacturing extension provide nesting capabilities to improve the component placement and maximize the utilization of tray volume and the printing efficiency. Okay. And on top of this, we also have an advanced extension for additive manufacturing. It provides the 3D metal printer connectivity and specialized capabilities to support and automate the creation of 3D metal printing support structures. The solution provides seamless connectivity to 70 to 80% of the metal printers on the market. It is developed by Materialize, the industry leader in the metal printing. It includes the Materialize Magic SG Plus kernel, this industry's leading additive manufacturing support structure generation tool. It is fully integrated within the Creo. Again, one thing I would like to reiterate here, any of the support structures can be fully edited by the user. It is one fully integrated system. The designs are modified and the tray positions are altered. All the support structures, everything will be automatically generated again.